Okay, so in this video here, we are going to take a little bit to look at something that's not really on the exam, but I feel weird not mentioning it. And that is another factor that affects solubility, which is the formation of complex ions. So far in chemistry, when we've talked about ionic formation of an ionic compound, we always say that a metal and a non-metal come together and it makes sure that their charges equal out, so that it's like Li plus and O2 minus, and they would come together to form Li2O. It would definitely have to be neutral. And that is not necessarily true. What can happen sometimes is that if you can have a metal ion and then something called a ligand that attracts to it. What the heck is a ligand? A ligand is usually an electron-rich molecule, or like water would be an example of that. And because this works very similar to what we've been talking about with the acidic cations and such, this can affect solubility. So I just want to show you this so that you know that it exists in case you see it again. But if you look in here, here's silver chloride. Silver chloride is insoluble. You can see the precipitate forming down there. But if I add some ammonia is NH3, and remember that is going to have a nitrogen with a lone pair on it. Because the lone pair is so negative, and the silver ion is positive, what we get is this really weird thing that forms. You can look at that. It is silver with two neutral ammonia molecules like attracted to it. We wouldn't really call this, it's sort of like an ion dipole. It is, I guess, an ion dipole effect. You can see the charge is still positive because what has been added to the silver is not something that's negative. It's a neutral compound. But because this pulls the silver out of the silver chloride, the solution looks like it becomes more soluble. Silver chloride is more soluble. And that's just because this weird complex ion has formed. This is like a whole other, this is KF. There's math that goes along with this. You do not need to know about this for the AP test. I believe it says qualitatively, not quantitatively. So all you need to know is that this can exist. This, though, definitely is on the exam. This is deciding whether a precipitate will form, which we've already sort of looked at a little bit, but this is what's called precipitation and separation of ions. If you have a mixture of two metal ions, which one will precipitate first? It's a way to separate a mixture of two metal ions. So of course, how do we decide whether a precipitate will form? We would be looking at Q versus KSP. And remember, Q is just like Q in the previous chapter 15, that it is the same formula as the equilibrium constant expression, except that the numbers aren't in equilibrium, they're starting numbers. And I would look depending on if Q is bigger than KSP or Q is less than KSP. If Q is less than the KSP, it will still dissolve, no precipitate forms. But if Q is greater than KSP, a precipitate will form. So here's a typical problem. Does a precipitate form when 0.1 liters of 8 times 10 to the negative 3 molar lead 2 nitrate is added to 0.4 liters of 5 times 10 to the negative 3 molar sodium sulfate? And what you need to, picture in your head is that you are mixing these two solutions in one container, which means that there's going to be a new volume and a new concentration of both of those. So you have to think about, first of all, what might precipitate out. If I have lead 2 nitrate and I'm adding it to sodium sulfate, think back to, first year chemistry, the positives and the negatives come together. So will sodium nitrate? Nope, sodium nitrate is always aqueous because sodium and nitrate are always soluble. It's this lead sulfate that we have to worry about. Lead sulfate might precipitate if the KSP, if when you compare Q and KSP, if Q is greater than KSP. So we have to look up KSP. So the KSP for lead sulfate is 6.3 times 10 to the negative 7. So now we need to calculate Q. In order to calculate Q, of course, it's just going to be the concentration of the Pb2 plus times the concentration of the SO4 2 minus. But I can't just plug in the numbers that are given to me in this problem because these concentrations are before they mix. I'm going to be increasing the volume, so I'm going to be decreasing the concentration. And how I figure out the new concentration is with a simple M1V1 equals M2V2, right? I'm diluting the solution. So that's exactly what's going on here. For the lead ion, right, the molarity is 8.0 times 10 to negative 3. That's my starting molarity. My starting volume is 0.1 liters. My new molarity is what I want to solve for, and my new volume is 0.1 plus 0.4 or 0.5 liters. So that gives me that, X, which of course is the concentration of the lead 2 plus, is 0.0016. And then I'm going to do the exact same thing, except I'm going to do it for the sulfate. The original molarity is 5.0 times 10 to negative 3. My original volume is 0.40 liters. My new molarity is what I want to solve for, and my new volume is 0.5 liters. Again, 0.4 plus 0.1. So that means the molarity, which is the concentration of the sulfate now, is going to be 0.004. And when I multiply those two numbers again together, I get 6.4 times 10 to negative 6. So, and this was the KSP for lead sulfate was 6.3 times 10 to negative 7. So this is a case where Q is greater than KSP, and yes, that means a precipitate will form. Okay, so that's a very common question. You can kind of see how you could maybe even do this in a multiple choice question if they give you really easy numbers. So this is the type of question, will a precipitate form? The other type of question that you will get is which precipitate will form first? And this becomes sort of important when you have to separate, or when you're being asked to separate a mixture. One of the hardest things that chemists do is separating a mixture of different substances. So this would be a scenario where I have a solution that has zinc and copper. Let's say, I think bronze is a mixture of zinc and copper. So if I had reacted, or brass, I think that we did earlier, was a mixture of zinc and copper. So how could I actually separate out the two? Well, I have to think of a property that is different between zinc and copper, and they have a lot of very similar properties. But one property that is very different is the KSP of their sulfide ionic compounds. So I add a little H2S. I just keep adding some sulfide, and see how this KSP is so much lower. So that means that the concentration that is needed to start a precipitation is so much lower. So I just keep adding a little bit of the sulfide ion till I get all of the copper sulfide to precipitate out. And then I pour off the liquid, right? If I pour off the liquid, then the liquid is what has left is just the zinc ion. And I can add more sulfide to that if I wanted to actually get the sulfide out. Okay. So this is a typical question for this. 17.17, a solution contains 1 times 10 to negative 2 molar silver ion and 2 times 10 to negative 2 molar lead. When chlorine is added, they both can precipitate. What concentration of chloride is necessary to begin the precipitation, and which cell precipitates first? So if I think about the KSP for, let's just do the AgCl, right? The KSP for AgCl is 1.8 times 10 to negative 10. And that, of course, would be equal to the concentration of the Ag plus times the concentration of the Cl minus. Well, the solution is already at 1.0 times 10 to negative 2. So I can then solve for the Cl minus, and that will be the concentration of chloride ion needed to begin precipitation. So 1.8 times 10 to negative 10 equals 1.0 times 10 to negative 2 times the concentration of the Cl minus, and the Cl minus concentration that would need to be is 1.8 times 10 to negative 10. That's the concentration of the Cl minus. So once I add enough Cl minus to reach that concentration, a precipitate will start. Let's do the same thing for PbCl2. The KSP for that is 1.7 times 10 to negative 5 equals the concentration of the Pb2 plus times the concentration of Cl minus squared. Don't forget about that. So let's plug in what I know. 2.0 times 10 to negative 2 times the concentration of Cl minus squared, and the concentration of Cl minus that is needed for precipitation is 0.029. That is much larger. So which one will precipitate first? This guy will be the first one to precipitate, because of course the concentration of the Cl minus starts out as 0 and then gets larger and larger and larger depending on like how much more Cl minus I actually add. So it will reach this number first, the silver will precipitate out, and then the only thing that will be left in the solution will be the lead ion. So this is a selective precipitation of ions. That's the last thing in this chapter.